Okay, let's make a summary of the power supply in the last few lessons. Through the explanation in the last few lessons, you may feel that our power supply is a little messy. How to fix it? We'll follow the course. Let's sort it out so that everyone has a clear mind. In this way, we will not feel that the content of the last few lectures had no idea in maintenance. So after the power supply circuit is damaged, what kind of failure will it cause? The most typical fault caused by the power supply circuit is that can trigger but nothing show on the screen. What is trigger? Or the current can be measured, the fan works, but the screen does not display. Can trigger on behalf of the standby, common point, 3 volt, these are all normal. There is no problem with triggering, but the screen does not display. In this case, we first connected the power supply to see the current. Then after the current power supply circuit is damaged, it shows two phenomena from the current, called trigger low current and trigger high current. What is triggering a low current? You need to connect the power supply to understand. It is necessary to understand the parameters of MacBook current. So what is the standby current of the MacBook? What is standby? It's the current state before we press the switch. Let's talk about it here. For all of our laptop, when looking the current, we must pull out the battery. Why? Since our charging affects our judgment, charging also consumes part of the current. When repairing, no matter it is a Windows laptop or Mac, when looking at the current, be sure to buckle down the battery. Please keep this in mind to avoid our misjudgment. Then the standby current of our MacBook is generally about 0.001A from the ammeter. There is also 0.02A. If it is too high, it is also a short circuit phenomenon. But if it is too high, generally a common point, 3 volt or 5 volt power supply short circuit. It can be lower than it, like the 0.00 is abnormal. Generally, it can be felt by a finger if the current is too high, because the short circuit part will get hot. We won't talk about this for now. When the times come to summarize, I will tell everyone how to repair the current level. Let's focus on the power supply current. In other words, the standby current is about 0.01A. In this way, it may be about 0.08 or 0.02, no more than 0.04. Remember this. Then the state of switch, if it is divided into two types. Press the hold key to jump from 0.01 ampere to less than 0.4 ampere. It may also be level 0.3 or 0.2 or 0.1. This is collectively called trigger small current. So what does it mean to trigger a large current? After pressing switch, the current pointer or current parameter is directly changed to more than 2 ampere. Also, the current jumped directly from 0.01 ampere to above 2 ampere. In this case, our power supply circuit is generally broken. It leads to the machine can be triggered but the screen does not turn on. From the current point of view, there are only these two phenomena. And then check our power supply. Remember this, okay? The Windows laptop are the same. Its idea is when it's in the standby state after clicking the switch. If these two situations occur, we must check our power supply. Laptop power supply is relatively easy to repair, so let's talk about how to repair the low trigger current. This is also very important. So how to fix the low current in it? In other words, after pressing the switch, the current is generally less than 0.4 ampere. But above 0.35 ampere, it is basically a normal phenomenon. So in this situation, where does the problem go generally? The first step is to check the power supply of the major inductors. That is PWM power supply. We have talked about when we talked about the power supply circuit. First check the inductor after triggering. Then 3V does not need to be checked again, because 3V is already working during standby. We only need to check the large inductor of 5V, the large inductor of the memory, and the large inductor of the bridge. At last, we need to check the large inductor of the CPU power supply. The voltage detection of each inductor must be normal. Let's talk about it here. Now the MacBook we repair is basically integrated. If the large inductors in the front of the power supply are normal, but the voltage of the large inductors of the CPU power supply is abnormal. Generally like this, if there is no problem with the power supply field tube and the chip, the chance of CPU failure is quite high because now they are all on board CPU. Apple high-end machines include from the second, third, fourth, and fifth generations. These are basically the onboard CPU. Please remember to make a note when repairing the power supply inductor of the CPU. If the CPU's power supply inductor is dead, your repairing test is MOSFET and chip. It's okay to replace all of them, and the conditions of the chip have been checked. In other words, the MOSFET is okay, the chip is okay, and the working conditions are okay. If there is no problem with these three guarantees, in this case, we generally determine directly it's a CPU problem. Add solder directly. If not, you can only change the CPU. We have repaired so many laptops, there is also the experience we get. But in daily maintenance, the cost of replacing a CPU is relatively high. Normal customer will not accept this price, especially the Mac produced in 2019 and 2020. Because its price is relatively high, the price of the CPU is more than 1,000. The price of the CPU is about 1,400 or 1,500 China yuan. The manual fee may be around 2,000 yuan, and some quotes are more than 3,000. The price of MacBook in China is like this. So when we encounter the low current, we first check the major inductors. But the major inductors are also searched in order. Can't check whichever you want. You must check the 5V large inductor first, and then check the RAM power supply, bridge power supply, the CPU power supply inductor. If there is a discrete graphics card power supply, check the power supply of the discrete graphics card. On the other hand, if all the inductor voltage are normal, the current is still low. In this case, find another power supply. One more thing to emphasize here. That means we must be careful not to miss these things. Second, if four electrolysis voltage are normal. However, the battery has a large charging inductor, which is present during standby. So there is no need to measure it, when all the large inductor voltage are normal. What are we going to check at this time? Open the drawing to find the power supply of the regulator. Light a lightning chip similar to this voltage regulator. Check the power supply of the regulator. We measured it on the circuit drawing just now, like this kind of voltage regulator. There is V in and there is V out. This is called the voltage of the VLDO linear regulator. You have to look up one by one because the number of the regulators in different laptop models are different. We need to check each one on the drawing, find out which regulator is damaged, and then repair it. But from the experience of our repair, if a small current is triggered, the large inductor circuit is damaged, accounting for 70% of the maintenance rate. Why do we have so many maintenance masters don't discard this point in the process of maintenance, including some writing materials when writing this part, he will not write. Why? Because he finds it troublesome. As a comprehensive master, from the technical requirement of the profession, only when we solve more than 90% of the problem can we be called a qualified master. From a technical point of view, what we have to do is perfect. I will give you a comprehensive explanation here, but it does not mean that you will encounter more such situations during maintenance. This kind of situation is rare. It does not mean it will not be broken. It's better for us to improve. In other words, all the large inductors are normal. You can find this voltage regulator in the circuit diagram. If it has input but no output, it is possible that a certain voltage regulator is broken. To find the circuit of regulator for repair, this is the second point. The third point, if the power supply for the regulator is also normal. So what should we check for the third point? Is there any voltage at the depot of the level-to-level power supply MOSFET we just mentioned? If the power supply for the regulators is also normal, at this time, we need to measure whether the depot voltage of the level-to-level power supply MOSFET is positive. So which MOSFET depot voltage is abnormal? If 3.3 volt is abnormal, I will repair the 3.3 volt. If the 5 volt is not normal, I will fix the 5 volt. But this must be remembered. Look at the drawing to measure. If we go for a blind test, it will lead to omissions. To ensure the operation of the second and third step, we must look at the circuit diagram. This is from a responsible and technical point of view. There is no such master who does not look at the diagram and directly measure it. The probability of damage to this circuit is relatively high. If you find that there is no voltage on the depot of the MOSFET, generally we just short circuit the S pole and the depot. This is a repair method of the triggers a low current. Okay, let's talk about how to repair the trigger high current. This kind of failure is also more frequent. Triggering a high current is also a power supply failure, which is also caused by the damage to the power supply circuit. Then press the switch and our current pointer. Generally, it's better to use a digital power supply for MacBook repair, but pointers are also okay. How do we usually repair things like this? If the current reaches 2 amperes directly, the motherboard short circuit. There is a severe short circuit in the power supply circuit. So what does it mean here? Our first step is to check the diode value of each inductor. See which inductor is short circuit to ground and repair which circuit. First measure the diode value of each inductor. This doesn't matter the order, but you can't miss it. We also mentioned it in the basic course. The inductor on the MacBook motherboard is more obvious. I will measure each inductor again. 5 volt as well as our RAM, bridge and CPU. We measured it all again. As long as we find that its diode value is 0, it must have a short circuit. Then when the diode value is 0, it was short circuit. We have told when we talked about the power supply circuit. Use the burn-in method to divide the front and back poles and eliminate them one by one. It will be much easier. I believe that when you watch our replay video, you can also see how this short circuit is solved. We mentioned in the last few lessons. I won't go into this detail here anymore. So if the diode value of each large inductor is not zero, what does it mean? The second is to measure the diode value of the dipole of level to level. Its diode value is generally zero, and one of them must be zero. At this time, you need to look at the drawing to measure. Because of different models, the number of power supply for the level to level is not specified. Depends on the line established by the engineer. The diode value is zero. Generally, the diode is subsequent capacitor. Generally, the dipole of our MOSFET. We just mentioned that the dipole of the level to level power supply will be connected to the capacitor. Behind is a certain IC or a certain device. If its diode value is zero, this is the MOSFET, this is the S pole, and this is the D pole. I first buckle this capacitor. Many of them can be solved by buckling this capacitor. It may be that the capacitor is damaged. If the capacitor is good but the diode value is still zero, it means that the device in the back circuit is broken. If the latter part of the circuit is a hard disk, it is caused by the hard disk. If it is a screen, it may be caused by the screen. This probability is higher. This is the second repair method of after triggering. If all the level-to-level diode values are not zero, the above are all normal. Then in the third step, we'll measure the diode value of the VOUT pin of the voltage. It's also easy to miss here. Trigger high current, 70% of the cases are due to the diode value of the large inductor is zero. These two short circuits accounted for less than 30% of damage probability during maintenance, between 20% and 30%. So why so many mobile phone repair only partly repaired? Many people couldn't fix it, so this part was left out. There are a lot of material that also mention this, and we have to fully explain this principle. Only in this way can we improve our technology and success rate during maintenance. So this is how to troubleshoot the fault caused by the damage of power supply circuit. Draw the conclusion. It can be triggered by the screen no light. The current shown as two processing schemes, triggering low current and triggering high current. I hope everyone can use my method for reference in the maintenance.